Okay, so think about this. In this question, they're making jewelry. Let's underline some important information. Some of the jewelry is 84% gold by mass, and the rest is 75% gold by mass. The jeweler needs how much? A total of how many grams? 15 grams of 80% gold. So what are you trying to figure out here? What is unknown? Read the final question. How much of what? Each alloy. So there's two different, so there's two things that are unknown. So let's come up with variables to represent that. Let X represent what? So X represents the what? The mass in grams of the first alloy, right? The first alloy is 84% gold by mass. And then let's choose another variable. Let Y represent the mass in grams of the second alloy. Okay, just start with defining your variables. Figure out what are you trying to find out in this question. Once we come up with the two variables, we can figure out one of the equations. Altogether, they need how many grams of gold? How many grams altogether? What's the total mass of both alloys? Go back and look at the question. How many grams are they going to use all together? So altogether, they need 15 grams, right? So if X represents the first part they need and Y represents the second part, how would you write an equation to represent the total? So X plus Y is equal to 15. This is the first equation. Whatever mass we use of the first alloy plus the mass of the second alloy, all together it's going to equal 15 grams. That's the first equation. We're trying to figure out X and Y. That's it. Now, they also tell us that they need 84% gold by mass. So whatever the mass is of the first alloy, you need 84% of that. How would you write that? 84% of something, yes, right? 84% of whatever the mass is. What do we use to represent the mass? We used X. So how do you write 84% of something? 0. She said it already. Yep. Then we also need 75% of whatever the mass is for the second alloy. So that would be 0.75Y. And it should add up to a total of, go back to look at the original question. Now this is where it gets a little bit confusing. But we need 15 grams of 30% gold. So it's not equal to 15, right? And it's not equal to 30. It's equal to, it has to be 30% of the 15 grams has to be gold. Sorry, that's an 80? Yeah. Sorry, I covered it. So it's 80% of the 15. How would you write that? Yes, 0.8 times 15, right? 0.80 times 15. Can you simplify that? What is 80% of 15 is 12. So it becomes 0.84x plus 0.75y is equal to 12. And that is our second equation. Very simple. Once you come up with the two equations, well, the question was asking you to find out how much of each alloy. So we're trying to figure out X and we're trying to figure out Y. Doesn't matter what method you choose for this. You can use substitution or you can use elimination. In this situation, what do you think would be an easier method to use to solve this? Sure, it doesn't matter. Maybe you want to use substitution because it would be easier for you to isolate one of these variables and then just plug it into the other equation. I want you guys to practice that now. Okay, so I chose substitution. So I've isolated Y in the first equation. I said that Y is equal to 15 minus X, and I'm just going to plug it in here. That's the method I chose. But I rewrite the second equation, and I'm replacing Y with the value of Y, which is 15 minus X. And you are just going to now isolate X. So distributive property, and then I'm going to combine my like terms take away 0.75x equals 12 minus 11.25. Just combining my x terms, my variable terms. Simplify. You're going to notice that your answer is going to be a decimal. You can round off your answer, okay? So it's approximately equal to 8.33 grams, which means that the value of the other alloy is going to also be a decimal. You can just round your answers, okay? Once I know x, once I figured out x, I can plug it back into the original equation and I can solve for y. Or I could plug it into this equation, because I've already rearranged it, right? Y is equal to 15 take away x. So that means y is equal to 15 take away, well, what's x? 8.33. So y is equal to approximately 6.67 grams. So the question was, how much of each alloy should he use? He should use 8.33 grams of the first alloy, which was the 84% alloy, and 6.6 grams of the second alloy, which was the 75% alloy.